Hello everyone, I'm K. Darshan from Pioneer Biomedical Engineering. I'm going to take the seminar on the subject radiological equipment on the topic of shielding and leakaging test in the linear accelerator. Introduction. A linear accelerator LINAC is a device that generates a high energy X-rays or electrons used for cancer radiation therapy. LINAC accelerates the electrons using microwave technology and produces the therapeutic beams. Radiation from the LINAC includes the primary therapeutic beams and the secondary radiation such as the scatter and the leakage. Shielding protects the patient, staff, and the public from the unnecessary radiation exposure. Components of the LINACs are electron gun generates from the electron beam, and the waveguide accelerates the electrons to the high energies. The target converts electrons into X-rays in the photon mode. Collimators shape and direct the beam to target the tumor. Treatment head houses beam modifiers and monitoring devices. Gantry and the couch allow precise positioning of the radiation delivery. Radiation sources in the LINACs: primary beam, scatter radiation, leakage radiation, photon neutrons generated in the high energy LINACs above 10 millivolt. Secondary sources arise from the interaction between these shielding and room components. Monitoring these sources is vital for radiation safety. Need for shielding are protects the radiation workers, patients, and the public from the harmful doses. Limits the radiation by exposure to acceptable levels defined by regulations. Required to meet safety codes by the organization by like the AERB, IAEA, NCRP. Ensures the radiation outside treatment area is below regulatory limits. Enables the installation of the high-energy LINACs in hospital and clinics. Prevents radiation-induced injuries and long-term health risks. Types of the shielding are primary barrier, secondary barrier, maze, and the door design also contribute to the door's attenuation. Barriers are constructed considering the beam energy and the room layout. Shielding designs varies for the different LINAC energies and treatment techniques. Shielding materials are concrete, lead, steel, and etc. Shielding calculations. Shielding calculations are the considers the workload, occupancy factor, use factor, distance, application of the 10th value layer TVL to calculate the barrier thickness, incorporates the regulatory dose limits for the controlled and uncontrolled areas. Shielding design examples are treatment water load layout including the primary and secondary barriers, placements of the maze and the door affecting the radiation escape paths, barrier thickness is determined based on the LINAC energy and use. Shielding geometry ensures the minimal exposure outside the room. Integration with the hospital architecture and the workflow, operational workflow. Verification by the dose measurements after the shielding installation. Leakage radiation in definition. Leakage is the radiation emitted from the LINAC head when the primary beam is blocked. Originates from the waveguide, collimators, and the scattering inside the head. Accounts for the small percentage below the 0.1 percentage of the treatment dose. Leakage radiation is the safety concern due to the stray exposure must be minimized by the design and verified by the testing. Leakage contribution to the whole body and occupational doses. Leakage testing overview. Performed during the LINAC acceptance commissioning ensure the LINAC meets IEC 60601 and AERB IS5 leakage limits. Checks that leakage radiation outside the treatment field is within the safety norms. Tests conducted ion chambers, films, and specialized detectors. Provides the baseline data for the LINAC safety certification, essential for the protecting healthcare personnel patients. Future trends and challenges. Increasing the LINAC energies and advanced treatments techniques raised shield demands. Rise of the MR-LINAC MRI combined LINAC requires a novel shielding consideration. Challenges in the retrofitting and old treatment rooms for the new technology. Balancing the patient safety cost and the facility space constraints. Importance of the ongoing research in the leakage reduction and shielding materials. Regulatory update data. Testing is critical to Linux safety. Proper design protects the people and the environment from radiation. Leakage testing verifies the operational integrity. Regular maintenance and retesting recommended, and the essential for the hospital regulatory compliance, and also ensures a safe and effective radiation therapy delivery. These are the references which I have referred from the books. Thank you.